CCTV design using SketchUp, making sensor lenses. In the previous presentations, you were shown how to use SketchUp to assess ConOps and create effective CCTV sensor deployments and designs in 3D. Now we will create graphical representations of sensor fields of view and explore how to represent other characteristics. Creating the lens. Simple. First step is to start with the imager. We need to understand the dimensions of common imagers. Some of the more common formats employed in CCTV are listed above. We're all familiar with these: the 1/4 format, the 1/3 sensor, 35mm sensor, which is used in many of today's megapixel cameras. But let's select the most common one that we're very familiar with, which is the 1/3 imager, and that has a 4.8mm by 3.6mm dimension. Now we're going to launch SketchUp. This is the standard template. It has the 2D figure shown. We're going to get the front view and then select that figure and delete it, as we won't need it. Next, we're going to zoom in on the point of origin a bit. We'll be creating a small box, so zooming in helps. Next, we'll select the rectangle tool and draw a rectangle around the point of origin. Now, SketchUp has an interesting little feature. Once you draw a shape, you can then look down over in the corner there, and we're going to need 4.8mm by 3.6mm for the dimensions. Well, the dimensions of the box we drew were 9 by 6mm. We can simply type in 4.8mm, comma 3.6mm for the X and Y coordinates, and then hit enter, and it will update the last shape drawn to those dimensions. Next, I'm going to select that shape we just drew, and then as you can see, another interesting feature of SketchUp is if I use the move key, SketchUp figures out as I go to the edges there that what I'm really trying to find is the center of the shape. I can then move that shape to the point of origin. Having it on the point of origin allows us to align the shape with all the axes. Makes things easier when we go to draw. Now I'm going to select that shape and then use the component creation tool, and let's call it the 1/3 imager, and create that as my first component. Done. Next, we understand that the distance for our purposes to the subject is going to be 10 meters. The width of the horizontal field of view coverage at that distance is going to be 2.66 meters. And next, height, or the vertical field of view coverage at the desired distance, is going to be 2 meters, which is just slightly above the 1.93 meters, which is the standard subject at the 95th percentile. If we run all these calculations, we come up with a field of view on the lens of about 18 millimeters. By the way, we're looking at using a 4:3 format. This is assuming a 4:3 imager format. Okay, select the shape. To double click on it to open that shape. Then we're going to select the push-pull tool. We select that face of the shape and begin the extrude process. Next, like we did before, we're going to enter the value of 10, in this case 10 meters, to go ahead and extrude that shape by 10 meters. We're now going to pan around to the front of the shape. Okay, so now we're working with an imager that is dimensions in the range of millimeters, but the field of view is in the range of meters. The precision there is significantly different, so I'm basically going to ignore the dimensions of the imager. What I need to do now is move the horizontal and vertical edges equidistant, so they have a 2 meter displacement between the vertical edges and a 2.66 meter displacement between the horizontal edges. So you see there, I select the upper edge, and I'm going to move him 1 meter up, and then I select the lower edge, and once I see the message saying that I'm on axis, I can then type in the value of 1, and there I'm on axis, and I can type in the value of 1, and that'll move that edge 1 meter down. I can now do the same thing with the left edge, but I move it out 1.33 meters, and then the the right edge, now the left edge, move that 1.33 meters, so that's a total of 2.66 meters. So now what I end up with is a face that is 2 meters high and 2.66 meters wide, which is the proper field of view. I can now select that shape, and I can enhance it a little bit by coloring it. So I have some colors already made up, and I hit my paint key and I select the color that I want. In this case it's blue, and it is a transparent blue. If I want to make that a little more transparent, I can edit the color a bit, and I can change the level of transparency there and make it a little more transparent. Then click OK, select the color again, and now repaint it, and you can see that it got a little more transparent at that point. Alright, one more enhancement I like to do is create a line right down the center. So draw a line beginning at the beginning of where the imager is, right along the green axis there, and maybe extending 1 meter past the front of the face. It just gives us a reference point and shows us where exactly we are within the field of view. It's a good reference when you're placing the image or trying to decide where you are, and just it's a helpful pointer. So we add that line in real quick, and basically just use the line select tool, draw it out there, enter the value in, and we're good to go. Next thing I like to do is then also add a little box here, which will represent the camera itself, right? So I just basically draw the rectangle, and same process as before. I'm going to rotate it a bit here, select that face again, and then use my push-pull tool and extrude it a bit to make a shape. I'm not too concerned whether or not it's maybe an oversized camera or really reflects. I mean, you could draw this to the actual dimensions of whatever cameras that you're using, but I'm really just using it here so that I have a reference, and I'm going to attach it to my shape because I use it as a handle. When I'm placing the shape or doing rotations, or I want to adjust azimuths, things like that. It just gives me a real convenient place to grab the shape and perform any manipulations that I need to do. So I'm just going through here and I want to change the color of the little box. So I've used my paint tool. I don't have a good solid color there. Let me go select the standard colors and select partial to blue, so I like blue, so let's make that blue. We got it blue. We close out the paint tool, select the shape again of the camera. Now I'm going to grab the camera shape, and then I'm going to actually, you'll see me jump ahead here, and I move it and connect it into onto the lens shape itself. Let's zoom out, and then want to make sure, I'm just looking here to make sure it's all aligned properly, and then I'm going to zoom out, and then select the entire shape, and use my component creation tool. I'm going to select it again to make sure I got everybody, and then use the component creation tool and make that my 1/3 imager, 18 millimeters, 10 meter standoff, and hit create, and then I'm done with creation of that shape. So now to explore the shape a little further and just validate that we've done what we thought we did, I can use my dimension tool here and select and put some dimension lines on here, and we got 2.645 in the one direction, 2.665 in the one direction, 2.004. Okay, well that 4, right, we know is the that's at the portion of the imager, but I can change my precision because I really only need about two decimal levels of precision. I might have made it there 1. That's probably a little too tight. Let me change that now back to 2 decimals of precision. So there we have it. We can see that the width is 2.66 meters, and the height is 2 meters. at that point. And if I add one more dimension here, we see that it's 10 meter standoff from the face of the imager. And now we have our basic shape that is a 10 meter standoff, 2.66 meters wide and 2 meters high field of view. Creating the lens in a more complex environment. Well, certain ConOps, certain requirements, such as we saw in the previous presentation, we looked at how to apply facial recognition requirements to our ConOps and our device. As another example, we could use the CCTV Operational Requirements Manual as published by the UK Home Office. It's a comprehensive document that defines operational requirements for CCTV. Operational requirements are defined in terms of observational requirements. What is it that we need to see? In these definitions, identify means that the figure subject occupies 100% of the screen height. Recognize is when the figure occupies approximately 50% of the screen height. Observe is when the figure occupies approximately 25% of the screen height. And detect is when the figure occupies around 10% of the screen height. Finally, monitor and control, in other words, just be able to know there's something out there, is when the figures occupy approximately 5% of the screen height. Well, let's say we represent, as we've done in our first example already, we use blue to represent the identify. And maybe perhaps we can then use, say, green to represent the 50% level. And then maybe we'll use orange to represent the 25% level. And then finally we'll use red to represent the 10% level. Okay, so now I'm going to start with my shape again. What I'm going to need to do is add a face to this shape and then extend it out 10 meters, because an additional 10 meters out, that'll basically double my field of view in the vertical direction to 4 meters. So to do that, I need to get the face all lined up, select my rectangle tool, and simply draw another rectangle face on the existing face, as such. Right, match it up exactly. Then I need to select that face, make sure I'm only selecting that face by itself, and I'm going to create that as a component. And let's call that, say, layer 2. Okay, and create that layer. Again, open it up, select my push-pull tool, and extrude that out, as I mentioned, 10 meters. So that I'll be doubling my field of view at that point. So now to represent that, and you see I've extruded it out 10 meters. Now I select the face of the shape again, open it, and like I did before, I select the upper edge and simply start moving it with my move tool. And when I see it's moving along the proper axis, I go ahead and type the value, in this case 1, because I want to move it 1 meter up, and I'm going to also move it 1 meter down. So I'm going to add 2 meters to my existing 2 meters, so I have 4 meters total. Do it with the side edges there, the vertical edges, and move that out. As long as I'm moving it on the axis, in this case I'm going to move it out 1.33 meters, and move this edge out here 1.33 meters. So I'm adding 2.66 meters to my original 2.66 meters. Again, doubling my field of view, which is what happens when I extrude out, go out another 10 meter standoff from my point of origin. And just to show that here, I'm going to annotate with the dimensional tool, and I have 5.32 meters, and I should have now 4 meters in the vertical, which I do. Now I'm going to select my paint tool, and as we discussed earlier, I'm going to select green for this next segment, which will represent the recognize area, where at the 20-meter position, the doubling position out there from the standoff, the field of view now is 4 meters in the vertical, which is double what it was at the 10-meter position. So it's approximately 50%. A person would figure would be about 50% of the field of view at that point. And at that point is where an operator should be able to recognize an individual. Okay, the next segment represents the 25% level. So we're going to need to create a face, as we've done before, and create a component, make that a new component, add that face, and then basically double the last field of view. So go from 4 meters to 8 meters for the field of view, which will do that by extending out that face, doubling the displacement we already have, which is 20 meters, and double that out to 40 meters total, so extend it out another 20 meters. So I'm going to grab the face there, push pull, and then extend it out, extrude it another 20 meters, so now the total from the point of origin is 40 meters. Then, just as I've done before, I'm going to go to that face. Now this time though, instead of doing it 1 meter, I'm going to go 2 meters in the vertical direction, up and down. So that's adding 2 meters up and 2 meters down. So that's 4 meters. It added to the original 4 meters will give me 8 meters. And then adding 2.66 meters to the vertical edges there. Grab those here and excuse me, and then move those out 2.66 meters each way from the center. So I'm adding 5.32 meters to the original 5.32 meters that I had, basically doubling everything. You see there's a segment. Then I'm going to select the segment, and as we discussed again earlier, I'm going to select the make that color orange, and I paint it orange. Now we'll go ahead and just validate this, and I'll use the dimensioning tools, and we'll put the dimensioning tools on the one field of view is 10.64, which is correct, and then the dimension on the horizontal should be 8 meters, and it is. So we're maintaining our angles. Still going to be an 18 millimeter focal length, except now this is a total of 10, then 10, and then another 20, so a total of 40 meters out is where we hit the area where the system now achieves the 25% level. Now I sort of jumped ahead here, and I'm showing what the next level out would be. This would be when we hit the 10% range, which the total there, if you think about it, needs to be a total of, 10% is going to be going out, we need a field of view 2.6, and we're going to need 20 meters in the horizontal. So basically there I need to go out by a factor of 10 from my original displacement. So that's actually at 100 meters distance from my point of origin. So I can cut and paste and take that model and drop it into, say, my green channel customs hall model, which we've seen in the previous presentation. I can understand where the different segments are there, the different fields of view, and what level of observation can be achieved at each area. The blue being the identified area, the green being the recognized area, and the orange area out there where people only occupy about 25% of the field of view would be the observe area. I can move that person over here and see that right about that position is where when they would transition from the recognize to the identify area, whereas people right out at the stanchion area, the entrance area there, would be just transitioning from the observe to the recognize area. And I can also see then that people that are farther out there in the orange area, they only occupy about 25% of the field of view out here. They would be in the observe area. If this presentation has been helpful, or if I can be of further service, please contact me. Thank you.